Good morning, all of you. Welcome to mathematics class 10. Today is 7th of September 2020 and it is mathematics. In the previous classes, we had already started the chapter trigonometry. We have derived some formulas and I've also taught you some techniques and tricks with the help of the diagram to remember all those formulas. Formulas are the key here, very important. So please write it down in that tabular form which I have already given and learn it every day. So let us continuing with the exercise, page number 324. Page number 324, exercise 8A, I think, yes. Exercise 8A, look at first question today. Let us do this question number 27 in your textbook. Question number 27. This question had come in ICSE in the year 2012. The question is like this: 1 plus cos A upon 1 minus cos A equals to, you have tan square A upon 1 minus sec A minus 1 the whole square. This is your right hand side and this is the left hand side. This is ICSE 2012. Now we have to start from the left hand side. So let us start. 1 plus cos A divided by 1 minus cos A. If you look at the right hand side, there is a square there. So you have to get a square. So in order to square that, we have to rationalize. There is a concept in the rational number, rationalization of the denominator, or you can also rationalize the numerator. But before we rationalize, there is a sec A and there is a cos A here. So we have to change that cos A, and we know that cos theta is 1 by sec theta. So let us replace that first in both the numerator as well as the denominator. So cos A is 1 by sec A, 1 minus, similarly down also you will get the same thing. After solving this, you will get like this: sec A plus 1 divided by sec A minus 1 divided by sec A. After solving this, and if you also see there, this sec A and this sec A, when it is reciprocated, they will cancel. So we come to this form: sec A plus 1 sec A minus 1. Now we are a little bit closer to the right hand side. If you look at the right hand side, you have got sec A minus 1. Here also we have reached the sec A minus 1, but there is a square there. So you have to get a square. In order to get a square, you have to rationalize. So this is a fraction. We can rationalize. Since we need same thing here, so we will rationalize the numerator like this. This will give you the equivalent fraction. The value of the fraction will not change. So this process is called rationalization. Now you have to multiply the numerator. I'll put this in the bracket as well. If you look at this two bracket, this is sec A plus 1 sec A minus 1. What does it remind you? It reminds you of the formula A plus B, A minus B. A is sec A here, B is 1. So the formula of A plus B, A minus B is A square minus B square. So we can get something like this. We have used the formula of A plus B, A minus B. If you go down to the denominator, both the bracket look same. So this will be sec A minus 1 the whole square. So we have come to the denominator of the right hand side. Now slightly we have one more step is there: sec square A minus 1 sec A minus 1 the whole square. Now this needs to be substituted by tan square A. And we know the relation from the trigonometric identities. The first relation was sin square theta plus cos square theta equals to 1. Second is your cosec square theta minus cot square theta equals to 1. And the third one is sec square theta minus tan square theta equals to 1. So this is the formula you know, or the identities. Now using this relation, if you transpose, if you bring 1 to the side and if you take tan square theta, what do you get? Sec square theta minus 1 will be equals to tan square theta. So in place of this, you can replace like this. So we can say that it is equals to your right hand side. So here we have used the formula of the trigonometric ratio. We have replaced cos A by 1 by sec A. Then this is simple, a simplification, taking LCM etc. These two will be cancelled. Then we have rationalized. Why did we rationalize here? Because we need a square. In order to obtain the square, we have to rationalize this. So these two we have applied the formula, that is algebraic A plus B, A minus B. Here we have squared the two brackets because the two brackets are same. Now here we have used this relation. So 2 times we have used the trigonometric relation. Like this. Here the most important thing is application of the formula that you have learned. Okay, application of the formula is very, very important. Let us solve another question there from the textbook. It is an ICSE question. This question has repeated 2 times. It has repeated. It will come again. Maybe it might come again in the year 2021. So please write down that question. It is in the textbook. Question number is 41. There is a root under. This is somewhat similar to what we did just now. 1 minus cos A, 1 plus cos A, everything is under the root. And in the right hand side you have got sin A upon 1 plus cos A. Now this had come in ICSE 2000. It had come in 2013. Now it may come after another 7-8 years, that means 2021. Now look at the left hand side, there is a root under. So this root under has to be removed. We have to get rid of the root under. In order to get rid of the root under, there should be square under the root. Like for example, if you want to get rid of root under, a square will give you a. Like for example, 3 square will give you 3 because this square and the root under cancel. Root under is to the power 1 by 2. So here, if you want to get rid of the root under, we have to get a square inside. So let us start. 1 minus cos A, 1 plus cos A. First check the trigonometric ratios inside, and on the right hand side there is 1 plus cos A, there is 1 plus cos A, so no need to change this cos A. Now you should only focus on making this whole square. So how can you make this square? We can make this square by rationalizing. Then we will get a square, then this square and the root will be cancelled. So first of all, let us make a square inside, and we have learned just now. Let us put this in a bracket. Now rationalizing, since we need cos A in the 1 plus cos A in the denominator, so we will do that. See, this step is rationalization. Everything should be under the root. Now these two will be multiplied, and we can see that this is in the form of a minus b, a plus b, so you can use the formula a square minus b square. And here it will be 1 plus cos A, the whole square. Let it be under the root. We are coming closer to this. Now 1 square is 1, so I have not written that. 1 square is 1. 1 minus cos square A, if you go to the trigonometric relation, the identity is sine square theta plus cos square theta equals to 1. So from here, 1 minus, if you take this cos square theta, you will get 1 minus cos square theta, which means sine. So we can replace like this. Now in order to remove the root, there should be square and this is a single term. So now sine theta is a single term, it has a square. 1 plus cos, sorry, not theta here, it is A. 1 plus cos A is also a single term because it is in the bracket, the square is outside. So this can be also written like this. Sine A, 1 plus cos A, everything we put in one square. Now try to compare this. This whole thing inside the bracket is looking like a single term, like A. The power is 2 and there is a root under. So this square and the root under cancel. So we get your sine A 1 plus cos A, which is same as your right hand side. So here, whenever you need a square in the trigonometric identities or the trigonometric ratios, to get a square, the process is to rationalize. So this is a very, very important process. Rationalization. Now rationalization, you can either rationalize 1 minus cos A, so it should be 1 minus cos A also. It depends on what you are multiplying, it depends on the situation, on the questions. So since here we need 1 plus cos A, we have to multiply with 1 plus cos A here. Alright, so here we have used the formula A minus B, A plus B. And here also we have used the formula, the two brackets are same, so it will be whole square. Then here we have used these trigonometric ratios. Then these two square we have made it as a single power, and this square and the root cancel, the root is removed. So finally what we get inside here, sine A upon 1 plus cos A. So therefore, which is same as the right hand side. Let us solve some more questions on ICSE. This is in the year 2015. Please note it down and you need to practice. A lot of practice is required. Okay, the next question now is, in the textbook, it is here, it is not in the exercise, it is an example number 6. And it had come in the year 2015. ICSE 2015. Write down the question. Cos A upon 1 minus tan A plus sine A upon 1 minus cot A, this is cot, equals to, on the right hand side you have got cos A plus sine A. ICSE 2015. So first we always start with the left hand side, not always. Often we start, only in some rare cases we have to solve the right hand side. Now we can see two fractions, two different terms separate here. See, cos A 1 minus tan. So cos and tan, they are slightly different. So we can write tan A as, in terms of cos, that is sine theta by cos theta. So let us substitute these two. Look at this arrow. We have to make it similar because cos and tan is not similar, not in the same trigonometric ratios. Sine and cot is also not in the same trigonometric ratios, because if you look at the right hand side, we need only cos and sine. So therefore, the first thing is tan A and cot A. You have to know the formula that tan A or tan theta is sin theta by cos theta. Cot theta is cos theta by sin theta. So let us replace that formula. Sin A by cos A. Just opposite of tan is cot. Now, if you solve this, I'm going to skip one step and directly do it. Cos square A, cos A minus sin A. After taking LCM, cos A, then this will be cos A will go up here and multiply. Similarly, sin A will go up and multiply here sin square A upon sin A minus cos A. Now they are similar. So we have sin A cos A, sin A cos A, so we can come to this. Now if you look at this, two rational numbers are there. Look at the denominator, cos A minus sin A minus cos A. Are they same? No, because the sign is different. So we can make this denominator same by interchanging their position. With that, the sign also has to change. So let us make the denominator same. When there is plus, if I want to make cos A minus sin A, so plus becomes minus. So it will be cos A minus sin A. Why did we change this? Because now it is easy for us to take the LCM. Now they are same. This plus has become minus because we have interchanged their position. So now what will be the LCM of these two? It will be cos A minus sin A. So what is the numerator? Cos square A minus sin square A. We have to get this. Now let me go through this quickly. This is the left hand side. Tan A, cot A we have changed in terms of sin and cos, cos and sin, because it is coming similar now. After solving this, we have interchanged, then we took the LCM. Now no need to apply any formula, we need only cos A plus sin A. So do you see anywhere cos A plus sin A? No, we see only cos A minus sin A. That also in the denominator. In the numerator, it is cos square A minus sin square A. Think in terms of the algebraic formula now. So this is A square minus B square. So what is the formula of A square minus B square? A plus B. A is cos, B is sin. Okay, so A is cos, A minus B is sin. So let us put in the bracket. In the denominator also we have this, so this also we will put in a bracket. Now what do you observe? This bracket into this bracket upon this, these two are same, everything will cancel. So what is left here? Cos A plus sin A. So this will be your answer. So now this is how you need to solve it. Okay, so here we have applied the formula. See, sin, tan A is sin by cos, cot A is cos by sin, cos A into cos A, LCM cos A minus sin A upon cos A. That cos A will go up and it is multiplied. Here also same thing, sin A minus cos A, sin A will go up and multiply. These two we have to make it equal so that it is easy for us to take the LCM. So how can you make it equal? You can interchange their position by simply taking minus common or changing the sign. So this plus became minus. So these two, now denominator looks same, so the LCM will be same. Cos square minus sin square. Here we can recall the formula: a square minus b square, a plus b, a minus b. In the denominator you have this, so these two brackets can be cancelled. So like this you have to solve it. Now there is one more question I am going to solve. Let us do it from the textbook, question number 38. All of you can see that question number 38, how it is solved. Then you try to do it yourself one more time. Then you practice the other question in the similar way. Let me write down the left hand side directly because this is a bit lengthy question. Bracket open, 1 plus cot A minus cosec A. Then bracket open, 1 plus tan A plus sec A equals to 2. So that equals to 2 is the right hand side. I have not written the question, so I have directly written the left hand side. But what is on the right hand side equals to 2. Please check your question in the textbook 38. Now this everything has to be reduced and simplified, and you have to get finally only 2. So now look at the bracket. Is there any square there? No. Cot A, cosec A is there. Tan A, sec A is there. So we have to write this trigonometric ratios. You have to make it so that there is some similarity between the two. You have to write in terms. You have to use that formula. This is the application. Application is, you cannot, suppose you know the formula of 1 cot theta is 1 by tan theta. Okay, and you know the formula of cosec theta is opposite of 1 by sin theta. But if I replace cot as 1 by tan and cosec as 1 by sin, then we do not find any connection. There are some trigonometric ratios, there should be connection when you change the formula. So that is called the application. So this is the slightly difficult portion here. So how can you connect so that you can apply that formula? So here the connection can be like this. See, cot we can use in terms of cos and sine, and cosec we know is 1 by sin A. So now there is some connection here. So that's why this formula is used. Similarly, tan is sin A by cos A, sec A is 1 by cos A. One point you have to keep in mind, unless and until you do not know the formula by heart, then this will become the most difficult. Now in this bracket, you take the LCM. Sin A plus cos A minus 1. Here also you take the LCM, cos A plus sin A plus 1. Now this and this you multiply. If you look at this, sin A plus cos A minus 1, cos A plus sin A plus 1. In the denominator you have sin A into cos A. Now there are 3 terms here. Suppose I make this as single term. I put a bar here. Now look at the 2 brackets. Suppose this whole thing is here. A minus B, A plus B. What does it remind you? A square minus B square. But what is A here? This whole thing. So it will be like this. A square minus what is B? 1. 1 square is 1. Let me write that. See, this I have put a bar here. So these 2, sin A plus cos A or cos A plus sin A, actually they are same. Alright? Because in the plus, even if you interchange their position, it will be same, but only when there is a minus then it will be different. So these two are same. So this we have taken as a single term a. So a square minus b square. Now here you use a very basic formula of the algebra, a plus b whole square. A square plus b square plus 2ab minus 1. Here we have used a plus b the whole square. A square plus b square plus 2ab minus this 1. Sin a cos a. We have to get only 2. There should be only 2 in the right hand side, but quite complicated. But if you see carefully, recall what formula is this. Go to the trigonometric identities. Sin square theta plus cos square theta is 1. Yes or no? Now we are coming closer to the answer. 1 minus 1 will be cancelled. So what is left in the numerator? So sin a cos a cancel. So this will be your answer. Alright? So now, like this, you have to go on solving. More practice you do, better you get with the application of the formula. Application of the formula comes with only a lot of practice, but before you start doing this, the formula should be learned by heart. Thank you very much. Let us solve more questions in the next class. Please do the home assignments, all the remaining questions, and you have to submit it in my WhatsApp page. Thank you very much.